Let's talk about something that is seen throughout the course of our life. Something we see a lot but we know a very little of it. It separates the day and the night. It comes in seven colors, but collectively we call it white. When comes to speed of light, it nothing can be compared to the power of its flight. Also, it is responsible for sight. What is that? It is light. So let's have a look of what we have learned till now of the chapter light. Let's have a recap of the chapter light. We will be first discussing the topic reflection of light. So we know that reflection is the bouncing back of light from a shiny surface. So let's prepare a mind map for it. So in the reflection of light, we have studied the laws of reflection. According to the first law, the incident ray, the reflected ray, and the normal will lie on the same plane. And according to the second law, the angle of incidence will be equal to the angle of reflection. And in the same concept, we have studied about the spherical mirror, which are basically of two types. One is the concave mirror, and the other one is the convex mirror. In a concave mirror and a convex mirror, we will have some terms like pole of the mirror, center of curvature of the mirror, focal length of the mirror, focus of the mirror, radius of curvature. So these terms are also included in the spherical mirror. Then we have also studied the topic, the mirror formula, which is the relationship between the focal length, the object distance, and the image distance of a spherical mirror. Also, we have studied about the real image and the virtual image. When we talk about the real image, we can say that real images are always formed by actual intersection of the light rays which are inverted and are formed on a screen. But if I talk about the virtual image, they are apparent intersection of rays. Means when the rays are produced backward or they are virtually meeting, then we call that we are getting a virtual image. And the virtual images are always erect and cannot be formed on a screen. Now let's have a look in spherical mirror. We discussed the image formation by concave mirror. So in this particular that means condition means situation part, we have studied the position of the object at different places of different position, as well as where I will get the image and what type of image will be, means that is the nature. When the object is at infinity, we found that the image is at focus, which is always a real image, inverted image, and a diminished in size. We can use the term highly diminished here. When the object is beyond center of curvature, the image will be formed between focus and the center of curvature, which is real, inverted, and diminished in size. When the object is at center of curvature, the image is at C, that is the center of curvature itself, which is again a real image inverted and the same size as the object. Now, if we place the object between focus and center of curvature, the image will be formed at beyond center of curvature, and in this time we will get the image to be a highly enlarged or highly magnified. Again the image will be real and inverted. Next, if we place the object at focus, so we will get the image at infinity, which will again be a real image inverted as well as highly enlarged image. Next, if I move the image within the pole of the mirror, not within the focus of the mirror, and that is between pole and focus, we will get the image behind the mirror, which will be virtual, enlarged, and erect image. So we discussed the image formation by a concave mirror. Now move on to the image formation by a convex mirror. We can see in the figure 1 that the light rays are coming from infinity. When the light rays are coming from infinity, they are diverging away from the mirror and appearing to meet at the focus, which is at the back of the mirror or behind the mirror. If I move to the other ray diagram, I can say that object is not at infinity but within a finite distance, and in this case also we observe that the image is formed at the back of the mirror but it is lying between pole and focus, as can be seen in the diagram. And this image is a virtual image, which is a erect image and the smaller in size. Now, let us have some questions based on the topic that we have discussed, that is reflection of light. Question number 1. In this particular question, AB and CD are two spherical mirrors from parts of a hollow spherical ball with its center at O, as shown in the diagram. If the arc AB equals to half of arc CD, what is the ratio of their focal length? State which of the two mirrors will form virtual image of the object placed in front of it and why. Now if I look at the figure, I can say that at the mirror, what if it is a AB mirror or a CD mirror, both are formed from the same spherical surface or spherical ball. We know that the distance from the sphere or the center of the mirror to the center of the sphere is the radius of curvature, and half of it is the focal length. Since it is in this case both the radius are same, so what will happen, they will have the same focal length. So both the mirror, whether it is AB or CD, both the mirror will have same focal length. It will not depend upon how much the arc is longer or arc is shorter. And if I ask which one will form virtual image, if I can see the figure properly or very minutely, we can say that AB is a convex mirror but CD is a concave mirror. So which mirror will form virtual image will be AB. CD also forms, but we have to think of the situation. The situation is that it will be formed only when it is between pole and focus. So this is my question number 1. As you can see here, it is given that it is given foreign 2016. That means CBSE has 3 boards. Means CBSE set the paper for 3 cases. One is outside Delhi, another one is foreign, and another one is Delhi boards. So this came for foreign students. Move on to the next question. A spherical mirror produces an image of magnification -1 on a screen placed at a distance of 50 centimeter from the mirror. What type of mirror it is? See, we have already studied in the previous classes that magnification, if it is a negative, then obviously it will be a real image. If you forgot about that magnification negative term also, just few minutes back I told you that real images are formed on a screen. If it is formed on a screen, you should remember that it is a real image, and the real image are formed by concave mirror only, not the convex mirror. Done? Then my next question is, find the distance of the image from the object. See, if the magnification is 1, -1, then minus V by U is equals to -1. That means V is equals to U. Means object distance is equals to image distance. Whatever is the object will place, image will be also formed at the same position. What is the distance then? The distance will be 0. What is the focal length of the mirror? We know that in mirror image formation, few minutes back I have shown you that if the object is at center of curvature, image is formed at center of curvature. Done? So here center of curvature, and I said that object distance is equals to image distance in this condition. That means the object is placed where? The object is at center of curvature. Means R is equals to what? 50. Means R equals to -50 you have to write. If it is -50, then what will be the focal length? It will be equal to -50 divided by 2 is the focal length. If I ask you to draw the ray diagram to show the formation, move on to the previous slide, you will find that we are drawing the what? Have drawn the ray diagram for this particular case. Means when the object is at center of curvature, image will also be formed at center of curvature. Done? So next, move on to the next question, that is question number 3. A student wants to project the image of a candle flame on a screen 48 centimeter in front of the mirror by keeping the flame at a distance of 12 centimeter from its pole. So if such type of question comes in exam, I suggest you to just draw rough diagram for it. So what you will do, the candle is placed at a distance. You need a candle, you draw the candle, draw the mirror and draw a screen. See, if I need a screen image on a screen, screen means real image. Yes, if I talk about the concave mirror, then how where I will get on the same side as the candle or not, on the same side as the object I will get the real image. So what I will do, suggest the type of mirror he should use, is directly I can write concave mirror because it is a what, real image. Second one is find the linear magnification of the image produced. I the magnification, we know the formula m equals to minus v by u. Now the next question is what is v and what is u. Read the question again. We have to the candle flame is image is obtained on a screen is 48 centimeter, means my image distance is 48, and since it is on the left hand side, then obviously my v will be minus 48, and where I have kept the object 12 centimeter, object distance is always a negative number, so minus 12 will be my u, minus 48 will be my v. Okay, so we got the magnification from there. How far is the image from the object? So 48 is my image position, 12 is my object position. So subtract it, you will get the object position. Sorry, distance between the image and the object. Now comes the ray diagram. I hope you can draw the ray diagram, because if I talk about 12 centimeter, it is between focus and center of curvature. So this is the ray diagram for this particular situation. Okay, then move on to the next question. That is, the linear magnification produced by a spherical mirror is plus half, 1 by 3. Automatically, when I have read the question, plus 3, 1 by 3 means the magnification is positive. Magnification positive means it is a virtual image. First thing. Okay, analyze this value, and state the type of mirror. We have to find out that, see, if it is a virtual image, it can be a concave or convex, both. But now which one, concave or convex? So what you have to think, you have to think that if magnification is large, means more than one. I told you in the class, if it is more than one, that is magnified image. Magnified image means it is formed by concave. But since it is 1 by 3, that is less than 1, so it will be what? Convex. Because we know that convex mirror forms virtual image which are smaller in size. Done. Position of the object with respect to the pole. It can be anywhere. If I place it at infinity also, it will be very small. And if I place at means we don't have any specific place. I cannot say that it is at center of curvature, because all the values are lying on the right hand side of a convex mirror. Done. For that reason, I will say that images means object is placed between infinity and the pole. Now you have to draw the ray diagram to justify your answer. So you have to draw this particular ray diagram to justify your answer. Yes. So these are the things that I want to discuss with you. And moving on to the next question. The image of a candle flame placed at a distance of 30 centimeter from a mirror is formed on a screen placed in front of a mirror at a distance of 60 centimeter from the pole. What is the nature of the mirror? Find its focal length. If the height of the flame is 2.4 centimeter, find the height of the image. State whether the image formed is erect or inverted. Okay, now it is very easy question. The image of a candle flame placed at a distance of 30 centimeter means it is object distance. u equals to minus 30 is formed on a screen placed at a distance of 60 centimeter. Means image is 60, means v equals to minus 60. Done. Now height is given 2.4 and we have to calculate focal length and also the size of the image. Which formula I'm going to use? I'm going to use the mirror formula. 1 by f equals to 1 by v minus 1 by u. So I will get the focal length from there. Next it is asked to find the height. How we can find the height? We can find the height by magnification equals to minus v by u. Yes, is equals to h dash by h. So I hope you can do it. And the image will be what you have to find out. It will be, I think it is, since it is in front of the mirror, so it will be obviously real image. And the size is bigger, so obviously it will be what? Enlarged image. If it is a real images are inverted in nature. Okay. So now let's have a recap of the topic refraction of light. So what are the things that we have studied in refraction? Let's look at it. In refraction, basically, we have studied the laws of refraction. The first law and the second law. First law is a similar, that is when light travel means the incident ray, the refracted ray and the normal will lie on the same plane. Second law is a different one, that is a sine of I by sine of R is a constant. It is a ratio, it will be a constant, and that ratio we call it what? It is the refractive index of the medium. Okay. Another thing that we have studied in the refraction part is the spherical lenses. Like the spherical mirror, we have spherical lenses also. And there are two types of lenses, mainly the convex lens and the concave lens. In concave lens, we studied image formation, ray diagram. Also in concave lens, we studied the same ray diagram and image formation. Important topic is lens formula and magnification. What is the lens formula? It is the relationship between object distance, image distance and the focal length of a lens, spherical lens. And magnification is similar to the first case, the mirror case, that is height of the image by height of the object. But another thing important here is that it will be m equals to v by u. Minus will not be there. The last topic of the chapter we have studied is the power of a lens. The power of a lens is the reciprocal of its focal length in meter. So when we say power of a lens focal length in meter, if the lens is a convex lens, the focal length will be convex lens, the focal length is what? Positive. So what will happen? Power will become positive. And if the convex lens focal length is concave lens, the focal length is negative. So power will be negative. So these are the things that we have studied in the chapter.